I want to introduce to you, Alan, I think is new to you guys, probably to a lot of you. Alan Klaiber's joined 2 years ago. You joined our faculty. He's an assistant professor in our department, is an energy economist. He has been doing a lot of great work, a lot of groundbreaking work on the impact of shale development especially. He came to us from Penn State University. It actually came out just recently that Dr. McFerrin was the player to be named later in that whole exchange. I didn't mention that earlier because I didn't want him to feel bad. So let me turn it over to Alan. Yeah, I know. No tax dollars were harmed. Don't worry.
Thank you, Matt. I appreciate it. And I thank especially Dean McFerrin and also the others for setting this up and organizing this and inviting us all here. So today, let's see if I can get this better. Today I'm going to talk a little bit about some work that I started when I was at Penn State, brought over, and have really expanded since coming to Ohio State. And that's to think about winners and losers in the shale boom. And in particular, what I want to think about is the impact of property owners. And I know Barry just did a great job of talking about the western half of Ohio. Now we're going to sort of shift gears and think about the eastern half of Ohio. And when I say property owners, I'm largely going to talk about single-family residential people. So when you drive through many of the eastern parts of Ohio and you drive down the country roads and you see all the 1-lot to 5-lot developments along these roads, I'm thinking a lot about those people as well as some of the farmers. And I'll talk a little bit about farmlands and the revenue potential from shale gas as we get into this. So to give a map, this is the county southwest of Pittsburgh. So that sort of blob that you see up in the top right there, that is Pittsburgh. This is Washington, Pennsylvania. If anybody's ever driven across into Pennsylvania, this is Washington, Pennsylvania. So very close to the Ohio border, which is sitting right over here. And all these little black dots that you see, the little specks that are hard to see, these are all single-family home transactions that have happened between 2008 and 2010 in this county. And all the little stars you see, these sort of bigger blobs that you see around here, these are actually unconventional shale gas wells that have gone into this county. And so you can see there's approximately 200 of these in this county in this picture right here, and there's approximately 3,000 housing transactions with many of these in these more rural areas that are located in close proximity. So I'm really asking the question of what is the impact to these people that are likely not getting royalty payments, not getting lease payments. They own very small plots of land when their neighbor, the farm next to them, does decide to lease land and shale gas operations start to move into the area. Do we see an impact? So to sort of set the stage for that, the answer is yes, we do see an impact. And I want to sort of think about why we might see some of the impacts that I'm going to talk about. So not everybody gets the same impact. That's going to be one of the big takeaways from this, is that it's very heterogeneous. It depends on where you're located in the landscape and also whether or not you're on things like public water, how much ag land surrounds your home, how close you are to roadways. So we're going to get very different impacts depending on where you're located. And there's good policy implications that come from that in terms of what could policy do right now that might lessen some of these impacts as we see more of this activity move into Ohio. So I'm going to talk about that and lead off in with these policy implications. So thinking about shale exploration. So to get an idea, I hate to put up just the Pennsylvania map. It's not quite as impressive if I put up the Ohio map. So I'll put up the Pennsylvania map for now because I just wanted to talk about the rapid expansion of activity. So with the projector, can we see? There's very few little tiny light-colored dots here. So you might see a couple light-colored dots sprinkled in up here. There may be a couple light-colored dots sprinkled in there. That was really 2007, 2008, when this activity was just starting in Pennsylvania. So it started off fairly slow. In Ohio right now, we're somewhere only in the low hundreds in terms of permits. In terms of Marcellus activity, we're very low. It's mostly Utica. In Ohio, this is mostly Marcellus activity. But by 2010, we had gone from just 50 permits, 100 permits, to something around 2,200 permits in Pennsylvania and 2,200 wells drilled. So we had this very rapid increase once they came in and they started to prove what the reserves actually were. So in Ohio, we're sort of in that stage right now. We're putting a lot of exploratory wells in the ground. The companies are figuring out where the sweet spots are, where the areas for future exploration are going to be. And in a couple months, we're actually going to see companies in Ohio have to release data on what their production is, and that'll give us a much better picture of where we think this activity is likely to happen. One of the reasons we're concerned about this, or we're interested in this topic, is because it results in a lot of land use change. And so here's a Google map. Both of these are Google image pictures. This is the same area in Pennsylvania. Right here is on the left. This is sort of a forested area. So unlike much of Ohio, much of Pennsylvania is these rolling hills, which is largely forested, very small ag land. Right? So it's very expensive to get in there. You have to put new roadways. You have to clear cut the land to get in. And you see here's a highway running along here, along this part of land. This is probably an old logging road that's running through here. And by 2008, when this expansion started to happen, you start seeing these big changes. So the first big change you see is you start to see these sort of square areas. Here, here's one, and here's one. And these are actually your well pads. So this is where they've come in. Each one of these is 3 to 5 acres. You clear cut it. You build up bring your equipment in. You put your derrick on, and that's where you actually do the drilling. So you see these. But there's a couple other things that you'll notice. Right here, I don't know if we can see it. I'll show it again in a minute. But right there is sort of a little tiny blue dot, and that is actually a water basin where they stored water. Each one of the wells you put in the ground, you need to collect between 2 and 8 million gallons of water. An average is about 4.5 to 5 million gallons of water to actually do this process called fracturing. That's where we put water under high pressure into the earth, and it breaks apart this dense shale rock, which allows the gas and oil to escape. Right? That's the thing that you hear a lot about in the news media. So this is the landscape change we're thinking about. And then you could imagine if there were single-family residential homes built along this highway over here or over here, the question is, what's the impact to those? If this was a farmer that owned all this land, right, he's probably doing quite well. He's probably leased his land for upwards of $5,000 an acre, and he's probably going to make somewhere around $2 million per well in terms of royalties. So he's probably doing quite well, but what is the impact to the surrounding landowners? Here's another picture just from a slightly different vantage point of a different well in Pennsylvania. And this gives an idea of sort of the size. So if you look at all the machinery or the land buildings and equipment associated with the farm, you can see that they're essentially farming right up to the edge of the well pad. And this is about a 3-acre well pad, which is where most of this activity goes on. And you'll notice a couple things. One is you'll see the high rig, right? So that's going to be quite visible. But you'll notice there's an awful lot of tractor trailers that have been left here, right? And so this is a lot of the support equipment, the diesel generators, and the other material that needs to be brought in to do this. So this does not include the well water that they're actually going to be able to push down this to do the hydrofracturing. A typical pad like this, what they'll do is they can drill in 8 different directions. So with horizontal drilling, it's kind of like a spider leg. You go down and you go out. And if you go in a particular direction, maybe you go this way for one, essentially you'll pick up this rig, you'll move it a little bit, you'll put it back down, and you'll go in a different direction. So essentially in going in the 8 different directions, they're essentially going about a mile out, and all of these directions like this as like a spider leg. You can think of it like that, so that they can extract all the resources within a big radius around this area. You have to acquire the mineral rights, so there's sort of no slurp the milkshake. You can't go down there and start sucking on the straw, I think. And just take it out. It doesn't flow, so this is in very dense rock, so you have to actually frack the rock to get the oil and gas out. Okay? So you have to acquire the mineral rights. Bonus payments, so if you're a landowner, you're thinking about leasing mineral rights, easily over $5,000 an acre, potentially over $6,000 an acre, and then you're going to get about an 18% royalty. A typical well could generate upwards of $15 million, depending on how productive the area is. So you're going to be making large sums of money if you're this farm here that owned that land. As I said, one of the big concerns people have is water quality. And so there's 2 places that water really show up in this process. The first is the hydrofracturing process, where you have to spend 2 million to 8 million gallons of water. Here's that settling pond before. You can sort of see this pond right here. This is where they were collecting water to use for that, where they were storing that 2 million to 8 million gallons of water before they were going to put it down into the well. You have to collect this water, though. So in many of these areas, there's not large sources of water. You're not going to turn on the tap and pay the local municipality for water. You're probably going to go to a local water body, collect the water, or potentially you might buy this water from landowners if landowners have large quantities of water on their private land. So there's really 2 places you can get this. What you do is when you get it on the pad here, you have some semi-trucks here that have chemicals in them, fracking materials, and you mix those together, and that's what you put down in the well, and that is the hydrofracturing process. Okay? So that's the first use of water, is the input. The second use of water comes when after you've done the hydrofracturing, anywhere between 20 and 40% of this water immediately comes back out within the first 30 days. And that water is mixed with chemicals, it's mixed with potentially salts, heavy metals, other things that have come from a mile down into the ground, and you have to do something with that water. Maybe you can recycle it, maybe you can store it on site, maybe you take it and you dispose of it somewhere. You take it to a treatment facility that actually can handle that water. In Ohio, one of the big things you could do is you take it to an underground injection well and you just inject it in another well deep into the ground, right, and then you don't have to worry about it. So there's lots of places where you could take it, but the big thing is you want to worry about spills. So you have to be very careful that you don't spill this water and you contain it, because that's what's likely to lead to any potential water problems in the area. And I'll show that in a second. In Ohio EPA has actually looked into fracking for a long period of time, 40 or 50 years, not the type of horizontal drilling we're talking about here, but other methods of fracking, and they've asked very detailed questions and done nearly 1,000 studies into water quality issues associated with fracking to see where the impacts are, and they're largely associated with spills. Not the fracturing process itself, but spills once it comes back up to the surface. So all of these little blue dots, I said you had to collect the water. So the black dots are these wells that we showed on the previous picture, and all these little blue squares, these are actually water withdrawal sites. So in order to extract this water, the large volumes you need for a large operation like we have in Pennsylvania with several thousand wells, you need many, many places that you can go and get water, and you want them to be fairly close to where your wells are actually being drilled so that you can limit transportation costs. And so as this activity picks up in Pennsylvania, you'll see not only the well activity, but you'll see these frequent transits of tractor trailers across the Ohio countryside as they're going from water withdrawal locations to the wells where they're actually going to do the hydraulic fracturing. Okay? So you'll see two sources of tractor trailers. One for the equipment and the setup, the sand, the fracking materials, and one, which is, this is the big one, is bringing in water, which you need for the hydrofracturing. As I said, you have to dispose of this stuff. 20 to 40% of this water, this 2 million to 8 million gallons, comes back up, and that's what you have to figure out what to do with. Initially in Pennsylvania, they tried to dispose of it at municipal treatment plants. They've since ended that. They realized that it wasn't actually a good thing. It messed up with the biological breakdown and biological processes at many of these plants. And so underground injection and treatment with reuse is currently what they're doing with most of this water. Underground injection is largely happening in Ohio. All of these are underground injection wells that can actually take frack water in Ohio. So you'll see if you drive along the interstates here in eastern Ohio, you'll see a lot of tractor trailers coming through with trucks that say brine on them. And that is a lot of the frack water that's coming into these underground injection wells. 50% of Ohio's injection waste in 2011 was actually out of basin, which means it was likely coming from Pennsylvania, New York, and West Virginia. And so a large volume of this water is being injected into Ohio wells. So there's a new demand for Ohio injection wells. The geology in Ohio makes it very easy to make an injection well. You have to get EPA certified from Ohio EPA. And so you're seeing a lot of new applications across, especially the eastern part of the state, for new injection wells. And this amounted to about 9 million barrels in 2010. So we've got a large amount of water coming into Ohio. If you decide to treat the water, one of the ways is you do some evaporation. So you actually take it to an industrial facility, you heat it up, you evaporate the water out, you recollect that, and then what's left is sort of these residual solid wastes, which you have to then take and dispose of somewhere. And this is probably the least regulated of any of the process of shale fracking and shale exploration. So you get these solid waste, and what are you going to do with them? Another source of solid waste is cuttings. So you have, as you're drilling down into the earth, right, you're putting a drill bit in, and some stuff is coming out, right? And those are called the cuttings, and you have to dispose of those as well. These can have heavy metals. They can have low levels of radioactivity, especially if you're in areas with high levels of radon. And you've got to dispose of these, right? So there's a real boom for landfill owners, which is sort of the missing story here. So a lot of people are applying for permits to take this waste. A lot of small landowners that maybe were previously doing agriculture and are no longer doing agriculture are applying to become landfills because it's very lucrative now to take a lot of this waste, right? There's a real demand for places where we can put this solid waste. There's very little oversight, particularly in Pennsylvania, where a lot of this is occurring. There's almost no oversight of the solid waste disposal. A lot of worry about water, very little worry about solid waste. This could lead to a potentially long-term problem, especially if there's containment issues, if there's sealing issues, or other leaks that might occur, right? So this is something that's really been missed. So all of these things combined have led to, in the public's mind, a real concern about environmental and health. Okay? And so when you go to these areas, if you do survey work, if you go out and talk to residents, they say, well, boy, I'm really worried about this fracking moving into my neighborhood because I'm worried that there could be contamination to my water. I'm worried about air quality. Maybe I just don't want to see the oil rig and hear the diesel generators. Right? So you get this real public concern when oil and gas companies start to move in. So the first concern people say is, well, what about my well water? So I might be on well water, so I'm collecting water from groundwater, probably 100 feet, 200 feet underground, right? This is essentially the depth of a well, so we're getting down here to the Utica Shale, somewhere in the 5,000 to 7,000 foot range. So you're not so much worried about the fracturing. Fracturing is only going to be a couple hundred feet on either side of the well when we actually make the fractures in the earth to let the shale gas come back up. But what you're really worried about is way up here at the top when you have this casement, did they seal that correctly? So are there going to be cracks in the casement? If there are cracks in the casement, it would be possible for some of the gas coming back up to seep into the water supply. Okay? So that's one of the concerns people have, especially if you're a residential owner with this fracturing, is how well is this sealed right here where it actually goes through the water table, the area that I'm actually collecting water from. So there have been studies that have looked at this, right, and they have found systematically higher levels of methane in places nearby shale gas wells, but they didn't have good data before the shale gas well went in. So it could just be that where they're putting the shale wells, there was a lot of methane in the area, right? That's why the natural gas looked so lucrative there. And so it could have always had high levels of methane. We just never knew. Okay? So in Pennsylvania, they did not do a very good job of collecting baseline data on what the environmental conditions were. So we have a real opportunity in Ohio to sort of fix that and actually do systematic water testing and water monitoring in these areas to see if this story is going to be the case. The other potential place is when you have spill contamination. Right? And so this is when these millions of gallons of water are coming back up and you have to collect them. Right? So if you're a nearby owner and you find out that they spilled 100,000 gallons of brine water into the nearby river or the nearby stream, right, that might be a much bigger concern. Right? It's very much on the surface. It's very hard to collect all of this water, and there are many incidents of spill contamination that have been documented, have been proven, and have been fined in Pennsylvania where this activity is occurring. And I'll show that map in a second. So as I said, the Duke study by Osborne and others in the Proceedings National Academy of Sciences found this systematically higher level of methane, but they don't have a baseline. So they don't know whether or not it was always the case that that is true. Right? Chesapeake Energy is one of the companies, among others, that now requires water testing. So they saw this and they said, boy, well, we could be sued for this, so we should be testing this water before we go into the area just so we know whether or not it's us or not. Right? So companies and private corporations on their own are starting to take this under consideration because they are worried about this. They do say this is a health risk if this is coming from us. So they're systematically testing largely to limit their liability. Ohio itself has conducted 1,000 investigations since 1983 related to fracking. Most of these were not, almost all of these were not horizontal wells, so these are typically your more shallow wells, maybe up to 1,000 feet. But they've done 1,000 investigations, and they've found no incidents where they believe water contamination was coming from the fracking process itself. So this is where I said that you could have a gap or something go wrong in the casement, and you get this leaking of methane. Ohio EPA has done 1,000 investigations. They say, no, they have not seen that. But they believe that many of the issues that they've seen are related to surface issues and are related to spills. Okay? So of these 1,000 complaints, many of them they did say, yes, there was water contamination, but it was almost exclusively related to surface issues. Okay? But this was a very different type of fracking, much lower pressures of water. So it will be interesting to see how this continues as we move forward. Right? But very much so on the surface. Okay? So are there incidents on the surface? All of these dots are actually environment and health violations that have occurred in Pennsylvania associated with non-conventional shale gas. And so this looks just like the well data I showed before. You get the same pattern. You sort of get this cluster up here. You get this cluster down here. Right? And many of these are related to surface spills and surface contamination. So the answer is yes. We do see environmental issues. We do see health impacts. This does not include things like wrong paperwork or administrative issues. These are actually environmental and health impacts that have been cited, investigated, and the people have actually been fined or reprimanded for whatever the impact was. So you see a lot of clean stream violations, discharge into ground. So this would be spills largely with the frack water as it's coming back up. They didn't collect it all. You see impoundment violations. So I showed that sort of square of where they were collecting the water. You also have some of these areas in Pennsylvania where you're collecting the water that's already come back up. That is the contaminated water you don't want to spill. They haven't engineered these correctly. They have impoundment violations. Similar non-structurally sound impoundments. These could give way. Right? Erosion into waterways. This is a big one, especially as you enter more hilly terrain. Right? So we do see impacts. Right? We already see impacts in Pennsylvania. And so while this might not be the top page on the newspaper, right, these are impacts that surrounding residents are aware of and surrounding residents are responding to when they think about risks to their property or risks to their homes. Okay? And so that's the kind of thing we're going to see if we can pick up. So here's the map again. So this is Washington County. All of the stars are oil and gas wells. And all of the little black specks, these are actually single-family home transactions. Okay? So I've stripped out agricultural. If you're more than 20 acres, I didn't include you in this, right, because that's a very different market, especially in areas where you're likely to have land leases. Right? It's a very different market. Okay? So we think that this impact might differ among different dimensions. So the first is whether or not where your water comes from. Are you actually reliant on well water, or maybe you get public water delivered to you? Okay? So if you were reliant on well water and that was your only source of water, you might view yourself as much more at risk if a spill or contamination did happen because you don't have another alternative, at least not another cheap alternative. Right? Another big question that shows up is who is liable. So as I said, Chesapeake now is trying to actually monitor this, right? But many of these companies, especially from the early exploration, were local companies. They've since been bought out. Ownership has changed 3 or 4 times, right? So if you did detect a problem down the road, it's very hard to figure out who would actually be liable in that case or whether or not that entity was still in existence, right? So many residents cite that concern. And then lastly, are there policy steps, that we can take to sort of limit any impacts that we see, if we see impacts? Okay? And so the idea here, and what I'm going to show now is actually some research on this. The idea here is we're going to compare property prices between houses that are very close to shale gas wells and houses that look structurally the same, that look identical, controlling for different attributes, controlling for distance to city, but that are not close to shale gas wells either temporally or spatially. And so controlling for everything else, then we're going to say the only difference between these houses is how close you are to shale gas activity. And then do we see an impact on your housing price from being close to that activity? Okay? That's the idea of where we're going. And this is joint work with another professor in AED economics, Satya Gopalakrishnan. So I just wanted to, if you can give her a shout out or shoot her an email if you have any questions, as well as me, since she's not here to correct me. So here's this county again, right? Here's Pittsburgh, here's the county. Large-scale activity in 2008. So this is when the activity really began in earnest in this county, when we started to really see this activity expand. Right? We've got very rural areas in much of this area where this activity is occurring, but we also have some more urban areas along the Allegheny County border where we do see some activity. So we've got both people that are in what we would think of as more of a suburban-type residential community, as well as people that are very much in rural-type areas along these country roads that we would see much of in eastern Ohio. So first, from a big picture standpoint, was shale good or bad for property prices in the area? So I went to my favorite, easy to access baseline price searching website, which is Zillow.com. They collect prices from all the assessors across the country, and they can actually plot sales prices. They do a very good job of removing foreclosures. And so what you see is this top line here is the housing prices across all of Pennsylvania. And so you'll go back, this goes back to, I believe, 2008. And so you see prices largely declining with the housing collapse, right, which is what we expect. They sort of started to stabilize by about early 2011, which is about right here. Okay? So this is what you would expect to see. Then you look at these areas where shale gas activity is occurring. And so this bottom line here, this green line, is Allegheny County. So this is the county of Pittsburgh. Right, so Pittsburgh, they had their bust a long time ago, right? Had their bust 10, 15 years ago. They weren't subject to this housing collapse broadly across the rest of Pennsylvania because they'd already busted, right? They'd done a lot of revitalization work. And you see that Pittsburgh's sort of been bouncing around. They've somewhat been stable here at somewhere around $95 a square foot for single-family housing. Then you come out a little bit farther from Pittsburgh, and this is Washington County. This is one that I've highlighted several times. And you'll see this market increase in the price of Washington County, especially relative to the price of Allegheny County. Right? And you start to say, well, what's going on here? Well, maybe a lot of people moved into Pittsburgh recently and they had to live in the suburbs. No, that's not right. You look at population numbers. Population numbers haven't seen this huge explosion of people in this area. Largely what's happened here is that this was the shale gas boom. And so you saw a lot of demand for housing, both for rental housing from temporary workers or people from out of state, but as well you saw a lot of people who started to get, some locals who started to get jobs on oil and gas rigs, and they would go out into the rental market and the housing market as well. And so they started pushing up prices. Right? So we see this big increase in prices. And so with this increase, it suggests very much so that landowners and landlords are probably big winners in this case, at least in the short term. Right? Because they're getting much higher rates for rentals. They're getting much higher prices for their property if they actually already own the land. The renters are the ones who are potentially going to be disadvantaged in this, and that they're paying much higher rents, especially people on affordable housing. A lot of the affordable housing that was in the affordable housing program down here at $80 a square foot, now that you can get $110 a square foot, that housing is probably not going to stay in the affordable housing program. So a lot of low-income people are going to lose a lot of affordable housing in this area. So that's the big picture. So we drill into the county a little bit, and we start to ask, what do things look like on the ground? And so I just zoomed in. Each one of these is about 1 mile radius. And it's sort of like playing, I don't know if you've seen the Where's Waldo book. It's very much like playing Where's Waldo. When you zoom into Pennsylvania now, you start looking with a fine-tooth comb through the pictures. When I first pulled this out, I thought there were going to be 2 well pads. I saw this one up here. You've got a fairly large water reservoir here, and here's actually the pad. And I saw this one here, so I pulled it up. And then I started looking closely, and I found another one here, and I found another one here, and I found another one here. And it looks like that might be another one that's in process down there. Right? And so you start seeing the landscape, and it's fairly well pot-marked with these shale gas wells because this is a very productive region of Pennsylvania in Washington County. You'll notice that these wells, I said each one of the radius of these circles is approximately a mile. You'll notice that these wells, there might be a little bit of overlap, but they're essentially a mile apart. Right? And that's a function of the technological limitations of horizontal drilling so that they can extract the full amount of resource under the ground by going a mile this way from this well and a mile this way from this well, and they meet somewhere in the middle. So that's the horizontal drilling. That's why you see this placement across the landscape. Also, what you can't see on this map, from each one of these wells, there are collector pipelines. So when the oil and gas comes up, you don't put that in a truck and move it somewhere. You actually put collector pipelines into the ground. And so from each one of these, there are collector pipelines and easements that have had to be made where companies have connected their pipelines to each other that are eventually leading to a compressor station that is getting put into a main trunk of a major oil and gas pipeline. Okay, so there's also that activity that's going on in this area. So in terms of winners and losers, I'm not worried about this farmer here, not in this analysis, but I am very much interested in what the impact of these residents that are living along these sort of suburban/rural roads that are in close proximity to this activity. Did they see an impact to their housing values? Zoom in a little bit. This gives another good picture. This is probably the landowner. Here's the well pad behind his house. This guy up here, you can see the beginnings of a driveway. This is the guy that may or may not, depending on how much land he owns. If he only owns this 1 acre right here, he may not be getting much of a lease activity. Okay? So he's the one I'm very much worried about. But here's another zoomed in picture of what this looks like. Another thing just to note is that this is fairly small. You'll actually see the remnants here in the winter of what were actually agricultural areas that were being used. Right? So this guy didn't have to shut down his operations just because he had oil and gas activity going on. Right? He was able to completely farm his land other than maybe this 3 to 5 acres right here where this well pad was. Okay? So as I said, we had 3,600 single-family transactions in this county. Right? One of the big things that we don't see, and that's one of the reasons we stopped in October of 2010, is that over time, all of this new income into the area, these increasing housing prices, local governments are going to do something with that money. So over a long period of time, it's quite possible that local governments come into these areas and they do infrastructure improvements or other things that start making the area nicer, maybe even than it was pre-existing the shale gas activity. Right? So we're really worried about trying to control for that. And so that's why we were going to limit ourselves at October 2010 before we started to see the tax revenues from the big explosion of shale gas activity in late 2010 show up. Okay, so we're going to look at some of the first part of this activity. We're going to think about counts of shale wells by homes. So we're going to think about counts as opposed to just whether or not there is one. The reason we're going to use counts in this analysis is we're thinking about the added activity of more truck traffic, the added activity of increased noise, of longer durations, right, which is very much a function of how many wells are going in there, not just whether or not there is a well pad. Okay, so the counts are going to pick that up. And we're going to use permit dates, which I'll show in a second, talk more about in a second, as opposed to the actual drill dates. The reason we want to use permit dates is we want to pick up the activity of building the well pad in addition to the activity while the fracking is going on. Okay? We're going to think about different spatial extents and also different temporal windows in terms of how close you are to the actual shale drilling activity. Just an idea of what some things look like. So the average sales price was $150,000. We had 1,600 square foot houses, and they're fairly large lot sizes on average, about 0.6 of an acres. So this is that more suburban, rural nature, much of what you would see if you drove through the countryside outside of Columbus. Okay, 9%, 8.8% of our sample is actually on well water. So much of our sample is actually in urban areas, right, in Washington County or in the outskirts, the build out from Pittsburgh, and is on municipal water. So we're going to be able to look for differences there. And then large portions of the county are agricultural forest. Okay? So large portions are agricultural forest, and residential makes up about 29% of the land use in the county. Okay? So it's pretty much what you would expect for this location. As I said, I'm going to decompose housing prices. You don't have to focus too much on this, but I'm going to decompose housing prices. So I'm going to take all these sales of individual housing prices, And I'm going to decompose them into attributes about the house itself, so square footage, bathrooms, bedrooms, garage, things you would expect in a traditional appraiser or on a traditional MLS sheet that would influence housing prices. I'm also going to worry about things that I don't observe. So the structure of Pennsylvania, they have many municipalities. So in this county alone, there's 62 municipalities in this county. And so each municipality has a slightly different tax rate, slightly different provision of public goods and public services. So I want to control for those. Right? And then what I want to start to measure is actually the impact of shale gas activity itself. And that's this thing here, this Z. When I say that, I want to think about interaction effects or heterogeneous effects for whether or not you're on well water or not. That would be this term right here. Okay? Or how much ag lands around your home. That could be this term right here. Okay? So those are the terms I'm going to think about in order to pick up not just a single effect, but effects that might be different across different people. As I said, permitting versus drilling. So in Pennsylvania, what you saw is depending on how far out from a well I go and how much time has passed between the permitting and the housing sale, this is how many permits I actually see in my data that are nearby residential homes. So if I drew a 3/4 mile buffer and I restricted it to only 3 months after permitting dates, right, I see essentially 35 wells that are very close to residential homes. Okay? As I get farther out, if I go 2 miles out and I look 12 months after permitting date, there's 210 permits / wells. These are only permits for wells that are actually drilled. I see 210 of these permits / wells that are within that distance and time buffer from a housing sale. Okay? So you see large numbers of wells within close proximity to housing, especially as you get farther out, 1 mile, 2 miles out, and you extend a temporal buffer a little bit bigger. How long does it take to go from permit to well? It goes anywhere from about 3 months, 3.5 months. Right? That's the time period from when you get your permit to when you actually, the drill bit hits the ground. Okay? So that's the construction, the clearing of the land, whatever you have to do to get your well pad set up. 7% of all of our transactions are within 1 mile and 6 months of a permit. So in that whole county, 7% of all housing transactions were near an active well. Just again, here's your wells. These sort of bold dots that you see here, these would be an example of housing transactions that are near a well, both in terms of timing and also in terms of where they're located. Okay. All right. So you can't really see that on this, but there is a water. So I'll just sort of draw it. This line right here is about where the water services area goes. It sort of snakes out here, comes here. And so people down in this area, people down in this area, and people in this area are not on public water. They're on well water. All right, so what do we see? So I'm going to zoom in on this. So here's a bunch of the controls for housing. I said we're going to be there. Here's a bunch of different controls for what your land use looked like. You might say, well, you know, shale wells, they don't go in the middle of urban areas, right? So we need to control for that. Right? So we control for different types of land use. I control for changes in prices broadly across time. I also control for changes in prices across municipalities. And I allow those changes to vary across years. Right? So I'm controlling for lots of things about changes in municipal tax revenue, municipal expenditure, things like that down here. And so what I'm really focused on is this square right here, which I'll blow up to right here. So if you think about a model, right, we're just going to look at the signs. I'll turn these into dollars in a second. If you look at a model and you say, well, how many shale wells are there and how close to the road are you? Right? The closer to the road you are, or the more shale wells you get, you see this negative effect. Okay? You see, so people don't like to be really close to a highway and really close to a shale well, which is the story that you see in the popular press about complaints about truck traffic. Right? So we very much see this complaint. If you're really close to a highway and you're really close to a lot of shale wells, you get this negative impact on your housing price. Okay? In terms of a top-line effect, what is the impact of just having shale wells near your home, right? We see this negative effect. Notice there's no interactions down here. So this is assuming that everybody's just impacted equally. Okay? And then in this column, what we do is we actually allow those impacts to be different depending on where you're located, whether or not you're located on well water and whether or not you're located near large quantities of agricultural land, which does two things. Ag land, the first thing it does is you might expect there to be more activity going forward, right? Because it's easy to access. The second thing is your line of sight. The visibility is much easier when you're along ag land, so you can really see the oil. You can see the oil rig and things like that from distance away, right? But we lose this top line effect. So it's very much a story of a heterogeneous impact. It depends on where you are in space in relation to the wells as to what your impact will be. So what about turning this into dollars? So a top line effect, if you just wanted to go out and multiply something together, right? So two different models here, both very similar. You're looking somewhere between $1,200 and $1,500 on an average house price. So $150,000 house, you're looking around a 1% drop just for the average home in this county, okay, from being located near a shale gas well. Right? If you were around a lot of ag land, so if you were in a really agricultural, very rural area, and you were not on well water, you're looking at somewhere between a $3,000 and a $5,000 impact on your housing value. So this is that you can really see it, you really know what's going on, you can probably hear the diesel generators, right? You don't have a big forest in between you and the well. If you're on well water and you're around a lot of ag land, greater than 75% of your surrounding land is ag land, you're looking at a much bigger impact. Now you're getting into the $8,000 to $10,000 off of your $150,000 home. Okay? So we see that this impact is very heterogeneous, and it depends on where you are. I will say right here, these might be some winners. So these are people, almost no ag land around them. They're on public water. These are people very much in the urban areas, right? Very close to developed areas. This was probably a one-off well. It probably resulted in increased tax revenue, which probably resulted in increased services. And so you actually see that for some small segment of the population, you actually see some potential gains. Okay? So if you expanded this out, you say, well, there's 500 homes near active wells in Washington County, right? And if you just took this top model, so you assumed everybody was the same, everybody was just average, what was this top model? This would suggest that there was an impact of about $625,000, $630,000 in terms of home values in Washington County from this activity going by. Okay? So then we asked ourselves, real quickly, well, how long does this effect persist, right? Is this a permanent impact on house prices, or does it go away? Right? Because that's very important. If you're going to make policy, you need to know whether or not you need a policy that's going to go over long periods of time, or whether it's a short-term effect. So you'll see right here, this top line, if we go from 1 mile to 2 miles, this road effect actually becomes a little worse, right? You actually see persistence in this road effect. You'll see the well water effect, right, drops away very quickly. So once you go to 2 miles out, there is no effect of being near being on well water, right, which makes sense given the technological extent of horizontal fracturing. Right? Horizontal fracturing goes out about a mile, right? You see this effect at 1 mile. By 2 miles, it drops out. And you actually start to pick up some of the winners, some of the agricultural, some of this general price increase. So in ag land, very negative if you're very close to the well, 1 mile. As you go 2 miles out, it actually becomes positive, and that's picking up that price increase I started the slides and showed you the graph of. You start seeing the general price increase across the county, but it's not true if you're very close to the well. If you're very close to the well. In terms of time, what happens? Well, you get this as you go from 6 months out to 12 months out. So now they've finished doing the fracking. They've probably completed the well. They're starting to close up shop. They've taken the rig down. They've moved on. You still see a negative effect, but you lose significance. I can't tell if that's different from zero. I can't tell if this is different from zero, right? But I still get a little bit of an ag effect even at 1 mile, right? And so this might be some of this expectation story. I'm really close to existing wells. It's likely they might come in and do more activity, so I still see this potential lasting effect. So what do we take away from that? So we find negative impacts, right? But these are very heterogeneous, right? It depends on where you are. It's more negative if you're near highways. It's more negative if you're on well water. It's more negative if you're near agriculture and you're close in time, okay? So close in space and close in time. We also see some long-run inflation effects, right? So we see this increased price in agriculture when you got farther away. We also saw a general price increase in the county, right? This is very much an inflationary story, right, that comes from this. And then most of these negative effects are short-term. The one exception is you see a persistent roadways effect. People along roadways are impacted much further out in time. So what does that suggest for policy? It suggests that anything that policy could do to help mitigate risk perceptions or adverse conditions during the drilling and fracturing period would be helpful. A lot of these effects go away after the oil rig is packed up. Right? So if we could stop these perceived impacts up front, right, that's largely where a lot of this effect is happening. So one thing which Ohio has started to do is they start to select travel corridors. So when you get permits, you also have to mandate where you actually want to have travel corridors to go to access the well site. And so you could think about requiring or putting new regulations on these to try to limit the impact to nearby homes by essentially specifying travel corridors through more rural areas or with fewer homeowners along roads. Another thing would be more systematic pre- and post-testing of nearby well water. And that would probably need to be coupled with some form of contingency plans or additional education about what the impacts or what the response would be if there were problems. So people don't see this risk perception going on. So people would say, well, even if this is a risk, I do know there's a solution out there. Okay? And so that would be another thing to do. This more persistent roadway effects, this suggests that despite the best efforts of Pennsylvania, they were probably unable to solve all the deterioration problems, right? So even though the oil and gas companies are supposed to come back in and do improvements after they're done in an area, the fact that this effect is more persistent suggests that more attention needs to be paid there, because it's probably not fully accounted for. And then lastly, this ag effect, it's really the visibility. And so thinking about if there's any visibility effects would be a good thing to design policy around. Can we limit those? Leave it off there. Thank you. Yes?
Alan, you had mentioned with our society exposed to inflation, the number of trucks per well, start to finish, we provide per well.
Yeah, so estimates, if you're bringing in all the water on trucks, you could be looking at upwards of around 10, how many trucks would you see for a well, was the question. And you could be looking at up to about 10,000 trucks for an individual well. And so if you figure it takes about 3 months for a well to be done, you're looking about every 30 minutes, 24 hours a day, a tractor trailer will go by your house. Okay? And so that's part of this roadway effect. Yes?
What's a well cost?
Well costs are typically in the $1 million range. They can be up to $2 million. It depends on how deep they're having to drill, depends on how far they're having to bring equipment, how easy access is. If you have to do a lot of the prep work on the well pad, it can go up.
Now the wells, they got it all drilled, they start drilling out. How long is that going to
So it takes about,
30 years, 20 years?
how long is it going to take?
How many years are they going to get off the oil?
So about 15 years is what they would expect to get. But most of the activity is in the first really 2 years or so. There's a really steep drop-off, or at least in the Marcellus, there's a very steep drop-off in production. So the profitable period of the well is probably going to be that first couple years. That's the biggest. Yep. But it's still going to produce for 15 to 20 years, but it's going to be largely upfront. Yep.
Does Pennsylvania's severance tax structure anyway mitigate the negative impact?
Yeah, so Pennsylvania passed Act 14, which lays an impact fee on unconventional wells. For a horizontal well, it's approximately $50,000 is the fee for one of these wells. And so if you took this top line number of $1,500 to $2,000, right? You say, well, how many homes would that fee cover, right? So if we had $50,000 loss, if there were 25 homes near the average well, okay, that fee would just be exactly the same as those costs. Now that money doesn't go back to those homeowners, but it does go, about 2/3 of that money goes back to local municipalities. But so they do have that. If you think about $50,000 and the average well is going to produce somewhere in the $8 to $10 million range, you're looking at something under right around 1% or a little bit lower if you had to put a percent of the royalties, which is what Kasich in Ohio is proposing, is to try to think about a 1% fee on unconventional wells as a royalty. Yep. Yes. Yeah, so there's two ways that happens. One is they try to avoid them at all costs because they don't want to get into negotiations with the small landowners. So essentially, they'll go in other directions away from those homes. The other thing that happens is if you get a certain percentage of homes nearby that have leased, they'll essentially give that lease rate to the people who are either the holdouts or the ones that they didn't negotiate with. So they'll get the average lease rate of their surrounding homes once you reach about 70% leased.
One person could stop a whole.
No. So once you reach a certain percentage of leased land in an area, they can essentially compel the other people to accept the lease. And so they can prevent that.
What percent of the gas and oil in a given area is one able to get out of these wells?
I don't think I've seen that answer. I'm trying to think. I don't know if anybody has anybody seen that number? I'm not sure what the total percent is. I don't actually think industry knows what that percent is because they don't have a good baseline of how much is down there. But yeah, I don't know what that answer is. What they were surprised of is how quickly their production fell off. They thought they were going to get much higher productions to extend much longer in time, and so they were surprised at that. So whether or not that means they'll have to go back in these areas and refrac to get more of it out, they're saying they won't have to do that, but it remains to be seen. Yeah.
I was confused by one of your comments there. As far as the lease requirements, mineral rights versus surface rights.
Yes.
In the state of Pennsylvania.
Yes.
Most other parts of the world, one individual can own the mineral rights and somebody else has surface rights, and the guy who has the surface rights is just basically the lot.
Yeah.
You just said that they have to negotiate with every single land.
If they own the mineral rights. If they own the mineral rights. If they don't own the mineral rights, then they're out of luck.
They
some do, some don't. So the new subdivisions largely don't own the mineral rights. These old, which were essentially split off of agricultural farms, like along these roadways, many a times those do still own the mineral rights.
And in many of those cases, those mineral rights are so fractured
Yes.
by multiple generations.
Yes. Which is why they try to avoid those at all costs from talking to industry. Because it's very hard. You don't want to. Yeah, no, that's right. Yeah, no, but that's right. So mineral rights, right, many of those are still intact, but they're fractured. Mm-hmm. Yep, that's a good question. Yeah.